Assalamualaikum. I'm Nurhasyimah from Rosli. I will present my research title Developing an Entity Relationship Diagram Database Structure for GIS-based analysis of recreational park accessibility and spatial proximity to residential areas. This presentation is organized into 4 main sections: introduction, methodology, result and discussion, and conclusion. Recreational parks are fundamental components of urban green infrastructure that contribute significantly to environmental sustainability, public health, and community well-being. Besides providing ecosystem services such as air quality improvement, climate regulation, and stormwater management, they also encourage physical activity, social interaction, and mental well-being. However, the benefit of these parks depends largely on their accessibility. Many urban areas continue to experience an equal park distribution, while some neighborhoods have convenience access while others remain underserved. Therefore, assessing accessibility has become an important issue in promoting equitable and sustainable urban development. Geographic Information System or GIS provide powerful tools for analyzing park accessibility through network analysis, service area analysis, and spatial proximity assessment. However, this analysis requires a well-structured database capable of integrating both spatial and non-spatial information. Although the expensive use of GIS, limited attention has been given to the conceptual database design that supports accessibility analysis. The objective of this study is to develop an Entity Relationship Diagram or ERD database structure that supports GIS-based analysis of recreational park accessibility and spatial proximity to residential area. Specifically, the study identify the required spatial and non-spatial database, formulate the entities and their attributes, and define the relationship among these entities to establish the comprehensive GIS database framework. The significance of this research is addresses the gap in conceptual GIS database design for park accessibility, provide the structure ERD integrating spatial and attribute data, support GIS analysis including network analysis, service areas, and spatial accessibility, facilitate evidence-based planning for equitable recreational park provision, and serve as a conceptual foundation for future GIS implementation and recreational planning. This study adopts a conceptual database design approach using Chan's entity relationship diagram notation to develop a GIS database structure for analyzing recreational park accessibility and proximity to residential area. The methodology consists of 3 main stages. First, the required spatial and non-spatial data identified. Second, the database entities and their attributes are defined. Finally, the relationship among these entities are established to create an integrated database framework that supports GIS-based accessibility analysis and evidence-based planning. The proposed ERD has 5 core entities that form the conceptual foundation of the GIS database. First, recreational parks represent the served destination, while the recreational areas represent the population served. The road network supports route-based accessibility analysis. Park access point define the park entrance used in the analysis, and the accessibility assessment identity store key indicators such as travel distance, travel time, and also accessibility levels. Together, these entities integrate spatial and attribute data into a unified database structure that supports network analysis, service area assessment, proximity analysis, and evidence-based decision-making for equitable recreational park accessibility. Stage 1. This stage identifies the spatial and non-spatial database required to develop the GIS database. Spatial database include recreational parks, residential areas, road networks, park access points, and administrative boundaries, which is a group support accurate accessibility and spatial proximity analysis. Meanwhile, the non-spatial database provide descriptive attributes such as park characteristic, population information, road properties, and access point details. The integration of this database established a comprehensive database framework that supports reliable GIS analysis and provide the conceptual foundation for developing the ERD, including the identification of entities, attributes, and their relationship. Stage 2. This stage identifies the key entities and attributes that form the conceptual foundation of the proposed GIS database. The entity represents the main spatial components, including recreational parks, residential areas, road networks, park access point, and accessibility assessment, together with their attributes. Structuring this database ensures that both spatial and spatial information are organized consistently, supports accurate accessibility analysis. This conceptual model also provides the basis for defining relationships among entities, which is essential for developing an integrated GIS database. The final stage focuses on identifying the relationship among these entities in the proposed GIS database. Using chain ERD notation, these relationships are represented with standardized symbols to clearly illustrate how the entities interact. Recreational parks have a one-to-many relationship with access point, while residential areas and recreational parks are connected through the accessibility assessment entity, representing a many-to-many relationship. In addition, the road network supports accessibility analysis by providing route-based travel distance and travel time. Overall, the ERD provides a clear conceptual framework that ensures data integrity, reduces redundancy, and supports efficient GIS database development and accessibility analysis. In conclusion, this study successfully developed a structured ERD model to support GIS-based recreational park accessibility analysis. The proposed ERD integrates key spatial and non-spatial database into a logical database framework, providing a strong foundation for network analysis and accessibility assessment. This framework can support evidence-based spatial planning and help improve equitable access to recreational parks. Future work will discuss on implementing and validating the database in a GIS environment and integrating additional demographic and mobility data to further enhance accessibility modeling and decision making. That concludes my presentation. Thank you very much for your kind attention. I will now be happy to answer any questions or hear your comments. Thank you.